Hi everybody, today we're looking at solving equations, and you may have done this in primary school, but here we go. So solving an equation is the process of finding an unknown. It's common in algebra to use a letter instead of a question mark or a square to introduce or to indicate different unknowns being considered. So let's have a look at what that means. If I have a question mark plus 6 equals 10, we want to think what number can we substitute for the question mark to make the statement true, to make this side of the equation the same as that side. Now in algebra, rather than using question marks or boxes, typically we use letters. So here I've put an A. I could have put any old letter. So A plus 6 equals 10. Just by looking at it or by inspection, we can tell that that value should be 4 because 4 plus 6 would make 10. And at the bottom here I've written what A is equal to. So even though just by looking at this we can say that question mark plus 6 equals 10 and the question mark would be 4, we can use guess and check and we can sort of figure it out. But later on the problems get harder and we need a more formal method of doing it, and that more formal method is called algebra. Well, solving algebraic equations anyway. Now there is another way of doing it. We can do it with backtracking. We can think, alright, well if we end up with 10 and we add 6 to some number, how can we find out what that number is? Well, we can work backwards. So we think about what the inverse operation of plus is, and in this case it would be minus. So if we go 10 minus 6 will give us 4, which from up here was the answer. The problem with backtracking is though, when the problems get a little bit more complicated, it gets difficult to know where you're backtracking. And at this stage you have to just take my word for it. But there is another method. There's the third method is called the balancing method, and that's the method we typically take into year 11 and 12. So we're going to start with that today, and that's pretty much the focus of this series of work. Before we can go to the balancing method though, we have to look at some naming conventions so that you can understand what it is that I'm describing. The first name that we have to learn is an equation, and an equation is something that has a left-hand side and a right-hand side and an equal sign in the middle. Now, there's lots of things that we can put on either side, and we need to be able to describe those as well. So the things on either side of an equal sign are called expressions, and there's a left-hand side expression and a right-hand side expression, typically written as LHS and RHS. And in the middle is an equal symbol. Now, even an expression can be broken down further. And in this case, we've got a variable or a pronumeral, this letter thing, and we've got some constants, the 6 and the 10, they don't have a variable with them. And anything that's separated by a plus sign, or on its own in the case of the 10, is called a term. So A is a term, positive 6 is a term, 10 is a term. Now we can break these down even further, but that's for the next presentation. Now, let's go back to what the balancing method is and figure out what an equation does. So with an equation there's an equal sign, and the equal sign indicates that whatever's on the left-hand side of the equation is equal to whatever's on the right-hand side of the equation. So if we consider 1 plus 2 equals 3, a fairly simple little equation, we know that 1 plus 2, if we add it together, does make 3, and we've got 3 on the right-hand side. So because this is 3 and this is 3, and there's an equal sign in the middle, we say that this statement is true, because the left-hand side does in fact equal what's on the right-hand side. Now this idea of sides of an equation is important because it's different to what we're used to. We're used to saying what we put on the left-hand side, we do it, and the answer turns up on the right-hand side. But in this case, we're saying what's on the left-hand side is equal to what's on the right-hand side. And if it wasn't equal to, we wouldn't be able to use this symbol anymore. It's two sides of an equation. If we get this idea clearly, the rest of this starts to make sense. So let's have a look. If we took the left-hand side of this equation and the right-hand side of this equation and added 3 to both sides, would the equation still be equal? Well, let's check. 1 plus 2 plus another 3 is equal to, so that's the 1 plus 2 there, that's the 1 plus 2 there, and we just added 3 to it. Then we took the right-hand side of the equation and we added 3 to that. Are the equations still equal? Well, 1 plus 2 plus 3 gives me 6, and 3 plus 3 equals 6, and 6 still equals 6. The statement is still true. So if we add the same number to both sides of an equation, the equation will stay true. Let's do it with subtraction now. If I subtract 3 from both sides of the equation, or in fact any number, will the statement stay true? We'll have 1 plus 2 minus 3, that's equal to 0. And if I have 3 minus 3, that's equal to 0. I've subtracted 3 from both sides of the equation. And the answer is still true. The left-hand side still equals the right-hand side. Different numbers, but they're still equal. Let's have a look and see if we multiply by 3. So if I multiply 1 plus 2, that would be 3 times 3 would give me 9. And on this side I've got 3 times 3 gives me 9. They're still equal. And if I divided both sides by 3, divide this side by 3, I get 3 divided by 3, that's 1. And on this side I'll get 3 divided by 3, that's 1. And 1 is still equal to 1. So the main thing to take away from this is as long as we do the same operation to both sides of an equation, the statement will stay equal once it's evaluated. Now we're going to try and use that to solve an equation. Now in this case we've got a plus 6 equals 10. What we really want to know is what would a be to make this statement true? By inspection we know that it's 4, because 4 plus 6 would be 10, and then that would make the left hand side equal to the right hand side. But now we want an algebraic method of doing it rather than just guessing and checking. So what we're going to try and do is we're going to make it so that on the left hand side of the equation we just have a, and on the right hand side of the equation we want the answer. And if we do the same thing to both sides of the equation, they'll still be equal. So let's have a look at what I mean by that. If we start with a plus 6 equals 10, what we're going to do is try and eliminate this plus 6 part. And if we did that and got a on its own, we'd be able to determine what a should be. So to eliminate the plus 6, which is the bit that's extra, the bit that's on the left hand side that we don't need, I would have to subtract 6 from it. Because 6 takes 6 would be 0, and a plus 0 is just a. So if I do that to the left hand side, to keep the two sides equal, I have to make sure that I do it to the right hand side as well. So subtract 6 from here, also subtract 6 from the other side, and lo and behold, if I do that, I get the right answer. That process is critical to understanding how to balance equations. And this is the balancing method. Whatever we do to one side of the equation, whatever we do to the left-hand side, we have to also do to the right-hand side. And we repeatedly do that until we find out what the variable is. A statement that looks like this. The trick is understanding which operation to do. And in this case, we've got a minus 3 equals 10. I want to make the subject of the equation a equals. To do this, I need to eliminate the minus 3. I need to eliminate this bit here. The inverse operation of minus 3 is plus 3, so I'm going to add 3 to both sides. I did it here, a minus 3 plus 3. And if I do it to one side of the equation, I have to do it to the other side of the equation or it won't be equal anymore. So a, if I add 3 to this side, this becomes a take 0. A take 0 is just a. If I add 3 to this side, I have to do it to this side as well. 10 plus 3 becomes 13. Let's have a look and see if that works. 13 take 3 equals 10. 13 take 3 is 10. 10 would equal 10. It works. So if we want to eliminate a minus 3, we would have to add 3. Example 2 is a bit more difficult. The x isn't on the left hand side. So the first thing we could do is we can just swap the sides. If both sides are equal, it doesn't matter what side they're on. And I want the x to be on the left hand side, so I end up with an x equals statement. So that gives me this here. Now I've got x plus 7 equals 14. Now I want to eliminate the plus 7, so I just have x equals on the left hand side. To do that, I want to subtract 7 from both sides. Subtract 7 from this side, I subtract 7 from that side. X plus 7 takes 7 becomes x plus 0. X plus 0 is just x. 14 takes 7 becomes 7. Bingo! I now know that 7 makes this statement true, and if we have a look at it, 14 equals 7 plus 7. 7 plus 7 is 14. If x is 7, then it becomes true. If x was anything else, if x was 1, 14 doesn't equal 1 plus 7. It's not true. For the only value that x is 7 would be if the only value of x that makes the equation true is when x is equal to 7. Let's have a look at the last one. 7 take x equals 14. Well, I want to make x the subject to the equation. The first thing I can do is eliminate this 7 over here. Now to eliminate the 7, I need to take away, that's positive 7, so I need to take away 7. So if I take away 7 from the left hand side, I have to also do it to the right hand side. That leaves me with minus x equals 14 takes 7 is 7. Now, I don't want negative x, I want just plain old x. To do that, I want to multiply both sides. To get rid of the minus, I want to multiply both sides by minus 1. Negative x times minus 1 will just give me x. If I do it to the left-hand side, I also have to do it to the right-hand side. 7 times negative 1 gives me negative 7. Let's check if that gives us the right answer. 7 take negative 7 would be the same as 7 plus 7, which will give me 14. The algebraic method has given me the right idea. Now, at this point, it would be best to go and do a good number of examples of plussing and subtracting just to get the idea of it. And then we'll have a look at multiplication and division in more detail over the next 2 little videos. Thank you, everyone. Hopefully that was helpful.